Okay, good to see lots of familiar faces here. So thanks for coming out. And yeah, I had to bribe some of my students with an extension on their assignment to come here, but it seemed to have worked me. Yeah, so I tried to come up with something that my students hadn't seen before, which was a bit of a challenge. And so I thought what I'd look at is a bit of review for my students in third year anyways about the Living Building Challenge and talk about sort of why that's important. How many people have heard of the Living Building Challenge before? Maybe half people, so good. So it's probably new for some people. And then I want to show how you could apply BIM to help to sort of meet that the requirements of the Living Building Challenge. So there's a lot of green building rating systems out there, going back to probably around early 90s when the BIM was first came out in London, in UK. And then it was adopted by the US Green Building Council in 93. And then that shortly after came to Canada as the lead green building rating system. Let's try in here. So there's a lot of other green building rating systems that came out of that, but the goal of those, generally, I would assume, the philosophy is to progressively get greener, right? The green building systems emerged because we had green buildings, but no, people were making all kinds of claims about how green they were, but there wasn't really any way to measure the greenness of a project. So as these projects, these rating systems have evolved, they've sort of become greener and greener. And so the one that I'm going to talk about today, the Living Building Challenge, claims to be the most stringent green building rating system out there. And so it's a difficult challenge to meet, but as we've seen, it has been achieved by a number of projects. And yeah, it's very interesting as they start to study some of these projects, they've actually found that some of them are even more cost effective than some of the less green projects that are trying to strive for things like LEED Gold or LEED Platinum and things like that. So really interesting area of sort of study and research in green building. I've also included the BC Building Code in here because, as some of you may know, they just introduced at Christmas time there a new stepped energy code for BC that the goal of that is to get to net zero ready for all buildings by 2032. So that's fairly soon. That's less time than I've been trying to create green buildings. So looking forward to that. So basically all the existing green building rating systems kind of fall into this red zone here. This is just a graph that tries to show the philosophy behind the Living Building Challenge. And so if you had sort of a standard code built building here, when the first green buildings came out, they were better than code, but they still had a negative impact on the environment. So the whole philosophy behind the Living Building Challenge is to try and stop making buildings that are less bad and start making buildings that are more good. And so when we start getting above this line here, this line where these two things intersect, you could call that sort of the net zero line, where a building would have zero impact, no negative impact on the environment. Then when you get above that, you're talking about something called a regenerative building. And so what is a regenerative building? So try and imagine a building designed and constructed to function like a flower, where it's informed by its location, its bioregion, determines its shape, its form. It generates all of its own energy from the sun, and it captures all its own water just from the sky. And it also has a positive benefit to the ecosystem. You can see there's bees there feeding off it, other plants, animals get things out of that, produces oxygen, and it's also beautiful, which is something that other green building rating systems sometimes ignore. So regenerative architecture is a building that has a net positive effect on the environment. And so how do we achieve this? Just try to be less negative and more positive, right? It's kind of, I think it's kind of an enlightening way of thinking about things. And so imagine buildings that have produced more energy than they use, or actually clean the water that comes onto their site. And the wastewater that's coming out of the site is cleaner than what the water that came onto it. So there's endless possibilities there. And so we have also the opportunity to go beyond just a building to make a neighborhood better, or make a city better, or even make the country or hopefully the world better. I don't know how readable this is. This is the sort of metric for the Living Building Challenge. I think it's fairly beautiful in its simplicity. There's 7 petals here. I call them petals because like a flower, right? And so to get full living building certification, you'd need to achieve all of these petals. And to get those, you have to achieve all of these 20 imperatives. You can also, within the living building, you can get what they call petal certification. So you would just get 3 of these petals here to get that. They also have their own net zero certification as well through the Living Building Institute. I kind of skipped that part, but the Living Building Institute came out of the Green Building Council sort of Cascadia chapter. And so I said before, they wanted something that would kind of go beyond LEED and try and really set a high bar, high standard for projects to meet. And when they first created it, they actually weren't even really sure if buildings were going to be able to meet that challenge. But now they have seen that there's a number of projects that have done that. And there's actually hundreds of projects that are attempting it now. So the Living Building Challenge defines net positive energy. This is in the current version, 3.1. You need to produce 105% of the project's energy on site. This is a net positive, so it means you're connected to the grid. You don't have to provide, it's not an off-grid building, it's different than that. So not so cost intensive, but now they do want you to have some storage so that if you went without power for I think up to a week, they want you to be able to run the lights and keep the refrigeration systems on, so your food doesn't go bad, I guess. So yeah, how do we achieve this net positive energy? As Matt mentioned earlier, it's pretty important to just get the consumption down, right? The renewable stuff, the on-site energy production is essential to getting the net positive energy, but you can't achieve it unless you have a really, really super efficient building to begin with. And that's sort of what I'm going to focus on today. So I got a few example projects. As I said, it's difficult to achieve this Living Building Challenge certification. This project in Penticton, Jim Patterson Centre, has attempted the Living Building certification, but hasn't met it yet. It's a picture of the roof there. This project has 1,100 PV panels on the roof, so they obviously got quite a bit of money from Jim Patterson for the project and spent most of that on PV panels, I think. But in spite of that, they did not meet the net positive energy goal of the project. And so I think there's a number of reasons for that. We went and visited the site, and I've looked at some of the details of the project. You know, you could look at things like building envelope. I don't think they put enough insulation in. There's always the users, right? We model these things on the computer. We can't always predict how people are going to use it. People open the windows, they leave them open, things like that. Also the building shape, it's not very efficient shape. And as Matt also mentioned, weird shapes are not really as very efficient, right? So yeah, and there's also some requirements of the Living Building Challenge. For example, you have to have opening windows in all regularly occupied spaces. So that could lead to sort of net energy loss in a project. So you have to consider some of those things. So this is another project at UBC. Attempting living building certification, but also hasn't met the requirements yet. They, when we visited here a few years ago, they had some issues with their PV panel system. They used the solar panels for sun shading, and some of them had burned out, and they're actually wired in series. They have different technology now where you don't have to do that, but they couldn't figure out which ones were burned out, and it's very difficult to replace them all. Go and check them out. So yeah, they had some issues with that. This building also has a really advanced water system in it, trying to meet the net zero water requirement, which of course in Vancouver they get a lot of rain. They can capture that. Use it for flushing the toilets. That's why they have these signs here not telling you not to drink the toilet water. It's very, very important because it's rainwater. It's not, doesn't have any chlorine in it. But they also have their own sewage treatment plant in the building using a sort of bioaquatics filtration. And they've had some regulatory issues with that, so they're still not able to use the rainwater for drinking water, for washing your hands or in the water fountains and things, but they've done some pretty amazing things there with the water usage. Last project I'll talk about just really briefly is the Van Dusen Botanical Gardens. This project did achieve living building certification for the PETAL certification, so not full living building, but did meet the net zero requirement. They were able to meet the net zero requirement because it's quite a small building, and they actually were put a lot of the PV panels out over the parking. So they weren't just limited to the roof area for the PV like some of the other projects, which can be really challenging. So they were able to do that. It is quite a weird shaped building. I should have put some pictures of the inside there. It sort of looks like a flower, which I guess fits with the living building. But I think, yeah, the shape would have been challenging as well from an energy usage standpoint. But yeah, they've done a lot of cool things with water usage and materials. They got some cool rammed earth walls and things there. It's a beautiful building. I'd encourage people to visit it if you haven't been there yet. So yeah, I wanted to kind of switch gears now and show you some software that I think could be used to make building designs more efficient. And so this is Autodesk Format. Has anybody used Format before? The one architect in the room? Yeah. So it's basically is Autodesk's answer to SketchUp. And but the interesting thing about it is it's web-based. So this is just me in Google Chrome here using the modeling software. It has a lot of the same tools as SketchUp for drawing, modeling, different shapes. You can even do quite complex shapes, doing you know, like sweep functions and Boolean operations, things like that. Yeah, so some pretty cool things there. I should say I'm not an expert in this. I actually just started using it a couple weeks ago because I wanted to, like I said, do something new for this presentation. So I thought, yeah, we'll check this out. Where I think this has the most, well, there's a number of things. It's intended to be a schematic design tool. So it's available for iPad. Apparently they don't have Android support anymore. But so you can draw on it with a stylus. So it's very kind of user friendly. But it's more for just start creating simple massing for a project like this. So I don't know how well you can see that, but my first year students here will recognize the site. This is a site that we're working on to design a carriage suite in the backyard of a house here in Kamloops. And so I thought I'd try this out because it's simple building and be fun to model. And Yeah, so you can go and you can add levels to your project just like in Revit. And you might be able to see this on my building here, but can you see the blue lines there? Those are the levels showing up as sort of slices through the building. And then it adds up the, areas together. So you can see I've got a 950 square foot building here. And yeah, I can input the site area, and it calculates the floor area ratio. So as you're modeling, and this will work quite well for a big project like a high rise or something like that, where you're working to an FAR target, because then you could play with the really weird shapes, but it's going to slice it up and immediately calculates the area for you, which I think is useful. I know my first year students often struggle to get accurate areas of their laneway house design, so it could be helpful. Also it's really quick to import your location, and you can just grab the satellite image from Google Earth and puts it right in there. You can see it in the background here, and you just start sketching right on top of it really quick. And shadow studies, you can see here, you can just immediately, once you got location, it knows where the sun's going to be at different times of year. So I could change the time of year here, and you can see the shadows get bigger, obviously, in the winter, shorter in the summer. You can change the time of day, so you can do quick solar analysis. It can also go here, and if I select different surfaces, like say I could select this roof, and I can analyze that, it tells me, if I can hover over it, it'll tell you the sort of BTUs per square foot of solar radiation, so the monthly peak, or you can do it a yearly kind of cumulative. So I can see here that I get about 1,100 something kilowatt hours per square meter of solar power on that roof. And so say, I wanted to rotate my building here 90 degrees. And I could do it again. That's doing the whole building now. But you can see it's pretty quick. And then I can see now I got 1,500 kilowatt hours. So I get another 400 kilowatt hours per square meter of power if I put PV panels on that roof. So you can use it to kind of tune your roof angle to maximize your solar harvest there for your PV panels, which is kind of cool. But the most interesting thing I think for me, as a sort of somebody who's interested in green design, is these tools here for looking at energy cost on your schematic model. So yeah, most of the tools in here are free. These ones cost money. I think it's $600 a year, I think, for this additional tools. But students, it's free, so you could hire a student if you're a company and you don't want to spend the $600, and they can do your energy analysis for you. But I think, yeah, the most powerful thing for this is so you can immediately get information back about how much energy your building is going to be estimated to use based on its shape. And so right from the very first day that you're sketching this building, you can get sort of a very rough, I would say, estimate of energy usage. And I'll try and quickly show you how that. I won't generate the model. It takes maybe 5 minutes for a simple model like this to generate the energy model. But then you can view it. You go to view inside here, and it goes to this sort of interface, different interface, and you can spin around the model, and you can see the different pieces here. It kind of breaks it down. It adds windows in based on, by default, I think it gives 40% glazing on each side. Sometimes it gets a little bit confused about what's a wall and what's a roof, but otherwise seems to work fairly well. But the key here is this number in the corner. That's it's really hard to see the units. Right now, that's $12 per square meter per year is the estimated energy usage for this building. And I've already gone through and I've kind of tweaked this but it kind of gives you a range here. You can see from $10 up to $14. So we're kind of in this, it's telling you you're kind of in that range depending on number of factors that you could do to make it more efficient. And so I've gone through here and I've adjusted some of these things. And you can see here how I've got a model history that I can go back to, and I can see all these sort of tweaks that I've made to the model. You can also click on this and it changes it to energy use intensity. So it's the number of kilowatt hours per meter squared per year. And that's starting to become quite popular in green building rating systems like Passive House. Theirs doesn't look at the whole building. Theirs looks at the heating load. EUI, it's called, energy use intensity, which is, sort of a measure of how efficient your building is.
So is that a default mechanical system, forced air, or is it,
I can show you here. We'll go down to the mechanical systems. My screen's really small, so it's hard to see. So here's HVAC. So you can go down to any of these things here and click on it. And then I can choose here between different ones. Probably won't be able to see the different types there. But so the difference here between, say, that's a high efficiency VAV, right? Where you wouldn't have that in a lane house. But see, that's 486 kilowatt hours per year per meter squared. But then I change it to a heat pump, drops down to 241. So you can see certain things make a really big difference. And other things, surprisingly, don't make that big of a difference. I was looking at the windows, for example. So you can look at window amounts. So say on southern wall here, I can change the amount of glazing. I've got it on for here, it prefers 95% is the maximum I can put, and it's telling me that's the most energy efficient because you see that's the lowest thing there. So it wants maximum glazing on the south, and then if I look at, say, the glazing type, sorry, that's the amount of shading on the window. The glazing type is this one. Glazing type, it actually prefers double glazed low E to triple glazed low E. So initially you'd think, yeah, triple glaze is always going to be more energy efficient, but not on the south side, right, in Kamloops, because we get a lot of sun usually, and it's still a heating dominated climate here, so it would actually save us energy to be able to get that solar radiation into the house. So yeah, so really quick kind of just rules of thumb here, but you can quickly kind of maximize your efficiency. So you can look at things, like I said, windows is a big one. Building orientation, you don't have to go back to the model and actually flip it around and remodel it. You can write in the software, it'll tell you, okay, you can rotate this 90 degrees, 45 degrees, different angles, and certain ones will be more efficient. In this case, the building is really simple shape, so it's not going to make a big difference in terms of rotating it around. But it does have some PV calculators here too, but I haven't looked into this yet, but it won't calculate them for Kamloops because it's saying the payback period is too long. But I know some solar installers in town that claim you can still get around 10, 15-year payback. So yeah, that maybe needs some tweaking. But let's go back to my slides here quickly. So I flipped through these ones. I did a couple other variations just to look at, see what kind of shapes, because this is where I think the power as a designer, this is what I want to do, right? I want to come up with options and look at, hey, what's going to be the most efficient thing for this site. So yeah, so I did this one, and obviously this one has a big roof area facing south. It's at an optimal angle, so it's got quite a high solar gain there for good area for putting PV panels. If I modeled this one, it came out quite a bit higher initially than the other one, and that's because for some reason it made this roof area have windows on it. It thinks it's a wall if it's not low enough.
Do you know if this uses the same kind of software as, say, Green Building Studio? Is it the same?
Analytical engine behind it?
Yeah, I think
Because
they're related.
I've had all sorts of problems with Green Building Studio in terms of recognizing geometry, and I'm just curious if it's the same platform.
Yeah, I don't know enough about it to answer that, but yeah, I'm kind of new to this one. I have used the energy modeling in Revit, and I did want to mention that that's possible.
So
But
GB and XML?
you can export this as a GBXML, yeah, I know that. Revit seems to work way better for more complex models. This is just for massing, right? But the cool thing is, because this is Autodesk too, is you can save right from the web-based platform to 360. You can open that Revit in Revit, that same file, and it's a Revit mass. And so then you can just start clicking faces and turn them into walls, roofs, floors really quickly.
Is there any way to put in like solar loads, occupancy loads?
No, it has a, one of the variables is for usage schedule. It doesn't have an option for type of use. So it doesn't care whether it's a school or a house or something like that. But you can say it's going to be used 24/7. You can say it's going to be used 12/5 or whatever. There's sort of about 8 different usage schedules. So how am I doing for time? You're standing here for a reason, right? Okay. So just to wrap up, I did do a few different models. Actually, the most efficient one was a box, right? So the builders are like that, right? We just want to build a box. But because when you do something with a peaky roof like this, it's assuming it's a cathedral ceiling. So really what you want to model in this, if you're using it for energy modeling, is the interior volume of the space, essentially, more so than the exterior shape. So yeah, so I've got some more experimenting to do. I think this would obviously work a lot better on a bigger project where the building shape and form is going to have more of an impact on the energy modeling. But yeah, I thought it's a kind of a fun tool, and I encourage people to check it out.
Right on. Thanks, Dale.
Thank you.
Yeah, Format is kind of like Autodesk's answer to SketchUp, and they've incorporated their analytical tools into it. And as you said, the beauty is you can import it into other Autodesk applications.
Yeah, you can even, from what I read, I haven't tried it yet, but import a SketchUp model right into Format and then do the energy modeling on that. And then you could import that model into Revit too. So it's sort of maybe better workaround for getting a SketchUp model into Revit, possibly. I haven't tried it yet.
Yeah, absolutely. And your presentation around the Living Building Challenge projects, I've been involved with a couple. One of them was the Jimmy Patterson project. I think it's reached LEED Gold Platinum.
Yeah, sure.
And there are some constraints around the site that are restricting us from getting to the Living Building Challenge. But it's interesting enough that I joined CEI at the time, just at the tail end of that project, and that was when we're actually transitioning into BIM. So it was actually done in AutoCAD. But it's a very interesting building.
Yeah, that's the kind of main point I think I wanted to make is that, you know, a lot of times as green building, you know, I've been doing green buildings for 15 years. You kind of rely a lot on rules of thumb and things when you're designing those. But now we have the power of this software to actually inform things right from the beginning. Right?
And you're right, and that's one of the things that I think what we're seeing in a lot of architectural firms is that early stage analytics, even if it's just a rule of thumb, to drive the design process. Like you said, you're going to tilt the roof up a little bit more to gain more maximum solar efficiency. So we're actually seeing that faster turnaround and influence in the design process for everybody, which is really interesting. Great, thank you very much, Dale.